Hello, it's Keith here, and this is lesson 12 of the platform-specific series of my Z80 programming tutorials. So we've been looking at graphics recently, but we're now going to kind of jump back a little bit. Before we were looking at how to read in the keyboard on the computer systems like the Amstrad and the Spectrum and things, and then to convert those into joystick type inputs where we had up, down, left, right and multiple fire buttons. Now we're going to have a look at the console-based systems we've been looking at over the last couple of weeks. That's the Master System, the Game Gear and the Game Boy and the Game Boy Color. And we're now going to do the same thing on those systems. Of course, those systems don't have a keyboard, so we're not going to read in letters, but we are going to read in the joystick inputs, and we're going to read them in the same format as we did for the computer-based systems, so that we can have the same code working on all the systems. And in case you can't guess, this code is in use in my Grime Z80 project, which is why I was able to make that game work on all of those systems, all 11 systems, in just 7 days. So this code is already in use, it did work, and because it's compatible, it makes coding really easy on multi-platforms. So you can see I've got two systems here, the Game Gear and the Game Boy Color. Of course, the Game Boy is the same as the Game Boy Color in this sense, and the Master System is almost the same as the Game Gear as well. So we'll just have a look at this one. So if I press the cursor keys, you'll see different bits in that hexadecimal FF for changing, and then if I press some fire buttons here, you'll see those change as well. And on the Game Boy, you can see the same button presses give the same bit response. So each bit in each of these bytes is a different button. And so you can test for multiple buttons just by testing for multiple bits. Now you'll see we've got FFFF. This is returned in HL. H is player 1 here, and L is player 2. Now these systems don't have a second controller, so there's nothing to read. But on the Master System, we are reading in the second controller. So if you're looking to do a two-player game on the Master System, you can. But both of these systems only have one controller, so there's no way of having a two-player game on the Game Gear or the Game Boy or the Game Boy Color. But anyway, so it's going to be a fairly quick lesson today, I think, but let's have a look at it. So here's the source code of today's lesson. It's basically based on the bitmap lesson we looked at before. So you've just got some init routines here, our font, but the functional code is really just this. So we're moving the cursor to the top corner of the screen. We're running this read controls function, which is the same as all of the other systems, as I've already said. So this function exists now on all of my systems, including even the TI 83 calculator. This returns HL. We then push HL onto the stack, and I just run this monitor testing function, which shows whatever was just pushed to the stack. So effectively, we're just showing HL to the screen quickly, and then we loop forever in this loop. So really, there's nothing to see here. The important thing is this player read controls dual function, which we'll have a look at on both of those systems in a moment. So let's have a look at the theory first. So the way we read the controls in is different on the Game Boy and the Master System and the Game Gear. Because the Game Gear was kind of an extension of the Master System, there is a few little differences between the two, so we'll have a look at those now. So the Game Gear and the Master System are a port-based system, so we use out and in to read and write to the devices. So in this case, we're reading in from ports DC, DD, and rather strangely 00. But we only read in 00 on the Game Gear, and that's because the Game Gear had an extra start button that wasn't present on the Master System. So that single button is in a different place. Now you can see the controls for player 1 are in bits 0 to 5 in port DC. Player 2's controls are mostly in DD, but rather strangely 2 of them are in DC, which will cause us a little bit of trouble. There is an extra third fire button, so to speak, for player 1 and 2 in bits 6 and 7, but I really don't know what devices use those. The general controllers don't have them, so I'm not reading them in because, as I say, they're not a lot of use. And you've got these very specialist ports which aren't really any use to us, so again we're ignoring those. Now, as I say, we're going to read in Game Gear start on the Game Gear, but on the Master System we're not going to. Our data will be read in and returned in a single byte for each player. So H is player 1, L is player 2, and bit 0 on the far right will be up, then down, then left, then right, fire 1, fire 2. If we had one, it would be fire 3, but these systems don't have one. And then the start button on the Game Gear for player 1. There's no equivalent on the Master System. So let's have a look at the code. So here's our read controls dual command. We start by reading in player 2. Now the first thing we do is, if we're doing the Game Gear, then there's actually nothing to do here. So we're just loading in 255 just to blank out all of the bits, because of course 0 means a button is down. If the joystick doesn't exist, we want all the buttons to be up. Now on the master system, we have to read in port DC first, and we have to back that up, and the reason is that we need these two bits here, which have got up and down, which we definitely want, of course. So then what we do is we shift in those bits into DD, because we need all of these bits as well, and then we just need to push down and up to the bottom of here, and then we need to, this will lose these two, which we didn't want anyway, and then we just need to fill in these two, which won't have any useful function. And that's what we're doing here with this OR command. So this is shifting in the bits of the buttons that were on DC with player 1's buttons, and then this is wiping the top two bits, which would be fire and start for player 2, which of course don't exist, so we want to just set them to not pressed, and then we just pop BC there just to get it back again. And that's player 2 done on both systems. Now player 1, probably slightly easier. On the GameGear, we have to read in the start button, which is on port 00 here at the top bit. So all we do is we read it in. We all the other bits to 1 to force them to 1, so only this top bit will be kept here, and we back it up into B, which we're using as a temporary register here. Now then we read in the bulk of the keys from DC, which you can see on both the systems is the majority of the player 1 controls here. We then OR it with 1 to set these two to 1. We then AND in this bit here, which will have the effect of, on the GameGear, bringing in the single button that we want, this start button here, so that we now have all of the controls of player 1. And at this point, we just return. So now we've got all the controls of player 2 when it exists, all the controls of player 1, including that extra button on the GameGear for the GameGear systems. Now, of course, this is all being done with compilation, so we're not doing any sort of hardware checking of the system to work out whether we're on a GameGear or a master system, because that's not really a situation that would be likely to come across in real life. While an emulator can run both, in general terms, you're not going to be expecting a GameGear game to be running on a master system or vice versa. So I do this compatibility with these conditional compilations, so you're not going to end up with a cartridge that would run on both systems, but I don't think that's really a problem here. So that's really all there is to it on the GameGear and the master system. A little bit tricky because of those strange key layouts and things, but nothing too complicated. Now on the Game Boy and the Game Boy Color, both systems are literally identical. They both have the same number of buttons. If you remember, the Game Boy and the Game Boy Color do not have out and in commands, so it's a memory address register on these systems. So all we need to do is use the port FF00, which is a memory address, so we're literally using our load command to write and read from that address. Now, rather strangely, despite the fact the system has 8 buttons in total, which is the directions up, down, up, left and right, and select, start, B and A, well, despite having enough bits for the buttons, for some reason they haven't laid it out like that. What we actually have to do is send a bit to this port saying, I want to read these 4 controls, and then we read in the 4 bits that map to those controls. And so we have to do that twice. Maybe this was so that they could support more buttons in the future, you know, by using these as toggles as well. But these are completely unused. Bits 6 and 7 do nothing. So, I mean, pretty clearly the Game Boy only has one controller. So controller 2 does nothing. So we've got fire 1 and 2 set to A and B. Select and start are fire 3 and the pause button. So we've got all of our controls mapped. But as I say, this will return basically the same controls as the other systems for compatibility if you're writing a multi-platform game. So let's have a look. So here's the Game Boy version. So the first thing we have to do is select the port. And the way we do this is we write a byte to this port FF00, which, as I've said, is a memory address, not a true port. And all we do is we set 1 bit to 0. And we either set bit 4 to 0 if we want to read up, down, left and right, or bit 5 to 0 if we want to read the buttons here. So first of all, we're setting 4 to 0, which means we're reading up and down, left and right. So we load that into the memory address, which tells the hardware which buttons to return. Then we read in from the memory address, and now we've got 4 bits worth of good data. Now right and left and up and down are unfortunately in the wrong order for what we want. So what we're going to do first, we're going to pop right and left into L as a temporary variable, because we know L is free because it's supposed to be being used by the second player, which of course doesn't exist anyway. So we pop off 2 bits via the carry into L. Then we pop off the bits we really want into H. Now we toggle bit 5 to 0, and this will select the fire buttons here, as you can see. We now shift over the bits that we had backed up temporarily in L into H, so that left and right are now in the correct position. We then read in from the port into A again, and this now gives us our fire buttons. And then we shift the A button via the carry into H, then the B button, then the select button, then the start button. And last of all, we set L to 255 because, as I've said before, there is no player 2, but we want the bits in that register to be valid so that if we read it, we don't think there's some player 2 frantically pressing their buttons, which wouldn't be very helpful. So we're keeping the compatibility with our common code by setting the player 2 where the player 2 doesn't exist so that none of their buttons are pressed down. And you can see at the bottom of both of these examples, I've just copy-pasted some notes from the documentation that I used when I was working out how to do this, just so that you've got, for completeness, the contents here. And there we go. So, as I've said before, but just to reiterate, this code is the same function-wise as the ones we've done on all of the other systems, as I say, the Sam Coupe, the MSX, the Enterprise. They can all work the same with this Read Controls Dual, and Read Controls Dual came originally from the Chibi Akuma's Episode 2 game, the 2-player version. So, as I say, it's got a good bit of a history to it with regards to its functionality, so I can say pretty safely that it's pretty good to use if you want to make a game on multiple systems. So really, I say that's what you should have a go with. And Grime Z80 is open source, so if you want to make your own little game and don't have a lot of time and don't know where to get started, download that, have a play with it. You can compile it with Vasm like I do here, so it's really, you don't need to buy any software to compile it, and you can download it for free and have a play. So there we go. Well, that's actually the end of today's episode. It was only going to be a very short one, which is why I've combined the two systems into one episode. So next week we're going to start looking at how to do palettes. We're going to look at the Amstrad CPC and the CPC Plus first, because they are my sort of original system, and we're going to have a look at how to set colours on those. But even though we're doing the CPC first, across all of the systems we're going to be looking at that have colour palettes, we're going to be setting those colour palettes in a common way, by which I mean we're going to use a 4 bits per channel definition of red, green and blue to define the colour on every single one of our systems. So we can use a common colour definition on our MSX, our Sam Coupe, our Enterprise, our Gameboy Color, so that rather than defining the same colours lots and lots of different times in different structures depending on that hardware's colour system, we can define it in one way and then use it across all the systems. And again, this was one of the things that made Grime Z80 and porting Chibi Akumas to the Enterprise very, very easy, because I didn't have to worry about reprogramming all of my palettes every time I changed systems. So I think that's something that's definitely worth doing. So hopefully you'll tune in for that. If you like this video, please give it a thumbs up. And if you're not already a subscriber to the channel, please subscribe so that you can see the stuff I'm doing in the future. Because I can assure you I've got lots more stuff coming up. Thanks for watching today, and goodbye.